So 4.1 is on properties of radicals, and we're going to start with just our basics of simplifying. Hopefully your paper looks a little bit better than mine, but the main goal for today is we're going to use properties to simplify expressions and rationalize the denominator. And then in the next lesson, we'll talk about operations with radicals. So a radical expression is just an expression that contains a radical sign. So remember that a radical sign is just our little root sign. Okay, so there might be a number that sits on the shelf, but the main idea is that you've got that little check mark. That's your radical sign. So an expression involving a radical with an index n is in simplest form when these three conditions are met. So you can't go any further if there's not a perfect nth power underneath the radical except for one. There's no radicands containing fractions, and there's not a radical that appears in the denominator of a fraction. So we don't like that square root in the bottom. And you can use the property below to simplify radical expressions involving square roots. And so they talk about how they're going to talk about how you can simplify. So if this was, it says the square root of a product equals the product of the square roots. So hopefully your paper looks a little bit better than this. But the main idea here is if you had numbers, I'm just going to kind of do that out because that's kind of weird looking. So if you have your numbers there, they're saying like if you have square root of 9 times 5, I think is what it said, then you could break that down to be the square root of 9 times the square root of 5. Or in algebra, if you have it as letters, a and b, then you can break that down to be the square root of a times the square root of b, as long as a and b are not 0. So the main idea is we're going to break it down using our factors, and you guys can use either your times table sheet, that factor sheet that I gave you, if you want one, or you can really just break it down into prime factors all the way. So you can either do it to the side or below. So I'm going to do it to the side, and then I'll show you below on the next one. So if I do it to the side, I'm trying to figure out 108 breaks down to be what times what. And if nothing else fails, you know that 2 will go into it because it's even. So if you don't remember it's 12 times 9, start with 2. So you could go 2, and that would be 54. And then you're like, what goes into that? And again, if you know your times tables, then you can do 6 times 9, or you can just do 2 times whatever. And you can keep going by 2 until it breaks down as far as you can go. Or you can jump in and do your times table that you remember. So 54 is 6 times 9. And then 6 breaks down to be 2 times 3. 2 doesn't break down any farther besides 1 and 2. 3 doesn't break down any farther besides 1 and 3. And then 9 breaks down to be 3 and 3. All right, and then as soon as you break it down further, then you can just kind of cross it out because we don't use them anymore. So once you've broken it down, then the whole idea is we look to see what the index is. And remember, the index is the number that sits on the shelf. So if there's not a number that sits on the shelf, there's an imaginary 2 that sits on the shelf, which means I need a pair, or I need 2 of the same thing in order for it to come outside of the radical sign. So I always think of it as a house. Okay, in order for you to leave the house, you have to have a friend or a partner so you don't get kidnapped. So you've got a pair of 2s, they can leave the house. So when they leave the house, they come out. You also have a pair of 3s, so they get to come out. And the only one that didn't have a partner or somebody that they are joining with is this little 3. And so because he didn't have a partner to leave the house, he has to stay home. And then we just multiply the numbers that are on the outside. So we're going to go 2 times 3, which is 6. And the radical 3 just comes out and attaches to it. And so this is my answer. If I'm doing 9x to the third, again, I can either do it below and break it down, or I can do it over to the side. So if I break it down this way, 9 is 3 times 3. It is 1 times 9, but that doesn't do anything for me. And then 3 doesn't break down, and 3 doesn't break down. And then our letter, our x to the third, means that there's 3 x's. And again, because there's not a number that sits on the shelf, there's an imaginary 2 sitting here. And so I'm looking for pairs. So I have a pair of 3s and I have a pair of x's. And so the 3 gets to go out, the x gets to go out. And again, this little x didn't have a partner, so he has to stay home. And this is my answer. So as we look at monitoring progress, I would pause the video right now and see if you can do the next 4 problems. And then once you've tried it, go ahead and turn it back on and see what the answers are. So for 24, we can break this down lots of different ways. We can either go 2 and 12, we could go 3 and 8, or we could go 4 and 6. And it doesn't matter because it all breaks down to be the same idea. So I'm going to do 4 and 6. 6 breaks down to be 2 and 2. And then, 4 breaks down to be 2 and 2. 6 breaks down to be 2 and 3. And again, once you break it down, we don't need them anymore. And then we look for a pair. So we have a pair of 2s and a pair of 3s. That's not a pair of 3s. I lied to you. You have a pair of 2s, and then you have 2 and 3 left over. So 2 gets to come out, and the 2 and 3 has to stay underneath the radical because they didn't have a partner to come out. And so when you do that, once you write down what's left, then whatever's left, multiply them back together. So this will be 2 underneath the radical is 2 times 3, which is 6. And we always multiply the values that are either on the outside of the radical or the ones that are left over on the inside. So when we do 2, same idea. 80, as we look at it, that's 8 times 10. As we look at 8, 8 breaks down to be 2 times 4. 4 breaks down to be 2 times 2. And then 10 breaks down to be 2 times 5. And again, I don't go further with 2s because it's prime, and I don't go further with 5 because it's prime. And then again, as I look at it, if I broke down 8, so I cross it out. I broke down 10, so I cross it out. I broke down 4, so I cross it out. And then when I go to write them on the outside, a couple of things that you need to notice. There's already a -1 sitting on the outside. So -1 is already out there. And then I'm starting to look for pairs. So I have a pair of 2s, and I can write it down. I have a pair of 2s, I can write it down. And then you have this little 5 that didn't have a partner, so he stays home. And then I'm going to multiply everything on the outside. So -1 times 2 is -4 root 5. And this is my answer. When I look at number 3, I'm going to break it down to be 49 is 7 times 7. And again, if you look at your little cheat sheet that has your factors, if you're not sure with your times tables, that's going to be helpful. X to the third is x times x times x. And again, there's not a number that sits on the shelf, which means I'm looking for pairs. So I'm just looking for 2 of a kind. So as you look for 2 of a kind, you've got 2 7s. So that comes on the outside. You have 2 x's. That comes on the outside, and this little x didn't have a partner, so it stays underneath the radical. And so then my answer is just going to be 7x root x. And then when I look at 75 n to the 5th, same idea. 75 is 3/4, so it's like 3 times 25. 25 breaks down to be 5 times 5. And n to the 5th, this part breaks down to be 5 n's. And again, we're looking for pairs. So we have a pair of 5s. We can kind of cross that one out because we broke it down. So we have a 5 that's going to come out. We have an n that's going to come out. We have an n that's going to come out. And when we look, we've got a 3 left over and an n left over. And so those are going to stay underneath the radical. And so then when we simplify, 5 times n is 5n squared. Remember, when you're multiplying, if they're the same base, we add our exponents, and there's really a 1 there. And 3 times n is just going to be 3n. So this is our answer. I think we'll just pause it for this video, and we'll do another one for when it's a division problem.